Hello, everyone. In the last lesson, we learned to create a Modbus server using Siemens S7-1200. Today, we will learn to create a Modbus client using Siemens S7-1200. With an example program, we will describe how to use a Modbus TCP client in a Siemens PLC to read and write holding registers and coils in an external Modbus TCP server. We will use Modbus slave to play the role of the Modbus server and the PLC to act as the Modbus client. In the same project, create a device named Modbus TCP client and a function named FC Modbus TCP client. Make sure to call FC Modbus TCP client in the main program, since we need to complete a series of actions such as reading and writing holding registers and reading and writing coils. We will use the state machine programming concept and switch states using step, as shown in the figure. When starting, prepare to read the holding registers. If reading the holding registers is successful, immediately switch to the state of reading coils. After the previous action is completed, immediately switch to the next action. In the Instructions, Communication, Other, Modbus TCP section, select MD client and add it to the function FC Modbus TCP client, as shown in the figure. If the value of the parameter disconnect is 0, and when REQ equals 1, the MD client call will be executed. No other calls to the same instance will be responded to until this call is completed. If there is no Modbus connection, one will be established during execution. When the value of disconnect is 1, the communication connection will be disconnected. When the value of disconnect is 0, a Modbus TCP connection will be established with the connection partner specified by the connect parameter. The connect parameter serves as a pointer to the connection description structure, with a data type of TON IPv4. The interface ID is used to specify the hardware identifier of the Siemens PLC's Profinet interface. The ID parameter uniquely identifies the connection in the CPU. Each instance of the MB client instruction must use a unique ID. The connection type parameter specifies the type of connection. For TCP, select 11 decimal. The actively established parameter is used to specify the ID corresponding to the way the connection is established. For Modbus TCP client communication, the client needs to actively establish a connection with the server. So it is an active connection and should be set to true. The remote address parameter is used to specify the server IP address that this Modbus TCP client needs to connect to. The remote port is used to specify the remote port number, which must be consistent with the communication port number of the Modbus TCP server. The default port number for the Modbus TCP protocol is 502. The local port is used to specify the local port number. Generally, we can just fill in 0. Done is an output parameter. If the last Modbus job is successfully completed, the output parameter done will be immediately set to 1. The output parameter busy is used to indicate whether a Modbus request is being processed. The output parameter error is used to indicate whether an error has occurred. If an error occurs, we can check the status to know the error information. The parameters described above are generic. However, the parameters MB mode, MB data ADDR, MB data len, and MB data PTR need to be filled in conjunction with the function code. The MB data PTR parameter is used as a pointer to the data buffer where the data to be received from the Modbus server or to be sent to the Modbus server is located. That is, the data receive buffer or the data send buffer. The filling of the other three parameters can be referenced from the MD client information system. The following lists the parameter filling for commonly used function codes. In this lesson, we learned to program a Modbus TCP client based on Siemens S7-1200 and explained the functions of each parameter of the MD client function. We used Modbus slave as the server to access the data that was previously set on the PC. That's all for this lesson. See you next time.